Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Find the constant b that makes g continuous on the open interval minus infinity to plus infinity, right? And we've been given g of x. So g of x equals x squared minus b squared if x lesser than 4 and bx plus 20 if x greater than or equal to 4, right? So like we solved in our previous videos, right? If I take a look at x lesser than 4, right, which is my interval minus infinity to 4, right, the open interval minus infinity to 4, folks. I don't think we need to worry about this because we have a polynomial function x square minus b square. Now b is a constant and that's what we've been asked to find. So I know that my function g is continuous, right, in this interval. Similarly, when I move to my part 2, before coming to the point where we will have to examine our continuity, I know that my part 2 is in the open interval x belonging to 4 to plus infinity, right? So let's write that down. So we have 4 comma plus infinity. And what is our function in this open interval? Our function is bx plus 20, which is a polynomial of degree 1. It's a simple linear polynomial. We know that this function is continuous, right? So let's write that down. So what are we left with now? We are left with examining the continuity at x belonging to x equal to 4, right? And for this function to be continuous at x equal to 4, we notice that the function g undergoes a transformation as we move through 4, right? So for values which are less than 4, we have x square minus b square. And for values which are greater than or equal to 4, we have bx plus 20. So let's take out what is our f of g of x at x equals 4, right? And I think this is straightforward. We can directly substitute it in the corresponding function bx plus 20. So what do we have? We have 4b plus 20, right? And for a function to be continuous, we need to evaluate our limit, right? So what is our limit? We have two limits to be evaluated. One is our left-hand limit when our function takes a value which is slightly lower than 4 and is approaching 4 from the left-hand side, which is what it means. And what does it call for? It calls for calculation of limits as x tends to 4 minus, right? And what is it that we have? We have our function x square minus b square, right? And when x approaches 4 from the left, right, we can substitute x with a value 4 minus h, the whole square. And what is our h? H is going to be infinitesimal and tending to 0, right? So we do a direct substitution of 4x here and we end up with 4 minus h the whole square minus b square, right? And if I replace my h tending to 0, what do I get? I get it as 16 minus b square, right? Because my 4 minus h is 4 minus 0 and 4 square becomes 16 and I'm left with 16 minus b square. So this is my LHL. And what is my RHL? My RHL is approaching uh, 4 from the right. So when I approach 4 from the right, I will have to calculate my limit using the function when g uh, of x for x greater than 4. And what is the function we have for x greater than 4? We have bx plus 20, right? And what do I need to do now? My x is going to take a value 4 plus h, right? Because we are approaching it from the right hand side. And when I do a substitution of h equals 0, because h is infinitesimal, I am left with 4b plus 20, right? So we notice one thing here. My LHL is 16 minus b square, so let me highlight it. And my RHL is 4b plus 20. And my g at x equals 4 is 4b plus 20, right? And for continuity, I need to have all these three values, right, which we have highlighted in yellow, to be equal, right? Now I know I'm going to pull out my pen. I know that my g of x at x equals 4 and my RHL are equal. So I don't have to worry about it. So the function is definitely continuous from the right. So we don't have to worry about continuity from the right. Now I'll have to be worried about continuity from the left, right? And how do I uh, check if the function is continuous from the left? For the function to be continuous from the left, my LHL has to be equal to my RHL be equal to g of x equals 4, right? And this is what we have from the rule book of continuity. And what does this mean? I know my RHL and g x equal to 4 hold good already, but for my LHL also to hold good, I need to have 16 minus b square. 16 minus b square equals 4b plus 20, right? That leaves me with, so for the function to be continuous, x equals 4, I need to have this condition met. And what is that condition? 16 minus b square equals 4b plus 20. And I do a simple rearrangement of this equation. I'm left with b square, b square plus 4b plus 4 equals 0. And what does this mean? This is nothing but b plus 2 the whole square, right? Because I have a plus b the whole square equals a square plus b square plus 2ab. So let me write that out. Let me bracket this first. And I have is equal 0, which means I solve for my b. My b is equal to minus 2. So for the function to be continuous in the interval minus infinity to plus infinity, we need to have b equals minus 2, right? So write our final answer for the function to be continuous. And what do we mean by belonging to minus infinity to plus infinity? All that we mean is x belongs to R, right? E equals minus 2, right? So that's how we go about solving this problem. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.